Welcome back, students. In this video, we will continue discussing solving some textbook problems. So far, we have covered all these topics, and I am discussing only the problems pertaining to these topics. So, in the last video, we covered some textbook problems. In this video, I will be discussing the exercises. The exercises come towards the end of the chapter. So, the first question goes like: a piece of wire of resistance R is cut into 5 equal parts. These parts are then connected in parallel. If the equivalent resistance of this combination is R dash, then find the ratio of R by R dash. So what the question says is, you have an initial condition where you have a single long wire with a resistance R, and then it is cut into 5 parts. Okay, and after that those 5 parts are connected in parallel, and the effective resistance of that parallel connection is R dash. So what they are asking, what is the ratio of R by R dash? So to visualize the scenario, it looks something like this. It's a long wire which a resistance R. After cutting into 5 pieces, each piece has a resistance of R by 5. How does this become R by 5? Recall our formula on the resistance. Resistance is equal to rho L by A. The L initially was 1 meter. Now it is cut into 5 parts. So 5 L becomes 1 by 5. So that's how I'm saying the resistance also becomes 1 by 5 for each of those parts. Now the cut pieces are arranged in parallel and connected to the power supply, power, whatever is the positive, negative, it is connected. And they say the effective resistance of this is R dash. So the solution goes this way. The wire is cut into 5 equal parts, which means each part has a resistance of R by 5. When the resistors are connected in parallel, the total resistance we saw in our video 8, that the total resistance of parallel connection is 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. So in this case, they have given the resistance of cut piece as R dash. So 1 by R dash is equal to 1 by R by 5, which I am writing as 5 by R. There are 5 such pieces. So 5 by R. When you add, it becomes 25 by R. When you add, it becomes 25 by R. When you cross multiply and take it to the other side, you take this R to this other side here. You get the value of R by R dash as 25. The next question is, how does the resistance of a wire vary with its area of cross section? The resistance of a wire is inversely proportional to area of cross section. It is again related to the same formula, that is resistance is equal to rho L by A, where A is in the denominator. So resistance is inversely proportional, means higher area lesser resistance, lower area higher resistance. So when the area of cross section increases, the resistance decreases and vice versa. Additionally, you can put the formula to start with. You can start with the resistance formula. R is equal to rho L by A. So I'm not solving every problem. Whichever is straightforward, I'm not doing it. Only those which is a bit tricky or need some calculation, only I'm solving that. So in the next video, we will discuss board problems around the topics so far we have covered. Bye and thank you till then.